Welcome to the second webcast of the Scientific Method module. Today we are going to cover graphing and specifically how to make a graph. So why graphing? Graphing is a way to visually show information. It makes it easier for the reader of an experiment to compare multiple variables. You need to understand what data has been collected. There's different types of graphs. Basically, in this class, we are going to look at our line graphs and our bar graphs. Occasionally, we will use pie charts. So, some different types of graphs. Again, I said line graph. That's the typical connect the dots. All right. We've all done one of those, and you draw a line to connect them. These are used to track changes over most times shorter periods of time. And there's a bar graph. We've all made this. This is to compare two or more variables. All right. So we have that. Sometimes we can use them in a few examples for larger changes over time. But for the most part in here, we'll try to use line graphs for change over time because our times won't be that large. And then pie chart. This is when we want to compare parts of a whole. So we can see what percentage was each of the variables. Okay. Here's some examples of each of those. Here's our line. Here's our bar. And then here's our pie. There's 7 steps to creating a graph. First thing we need to do is draw and label the x and y axis. The x is going to be horizontal. The y is going to be vertical. In your notes, I would like you to actually write these notes down, but also draw one example so you're able to understand what is going on. And at the end of this, you'll practice with one. We label the x and y axis. That means we need to put an actual title over here. Let's say we want to study the number of tomatoes harvested, depending on the amount of fertilizer. So here we would have tomatoes harvested. I'm just going to abbreviate this. You would, of course, write it all the way out. Tomatoes harvested and amount of fertilizer. Another thing we can do here is that we need to make sure we include the label of each of the type of measurement we're using. Here we don't really have to because we have numbers, 1, 2, 3, 4, 5, whatever it is. But over here we need to know what amount are we using. Let's just say we were using milliliters. We may have 0, that was our control, 1, 5, 10. And then we can compare these results. Also make sure that we always have our dependent variable is on the y-axis. And our independent variable is x-axis. Number 3, you need to decide on what intervals you will be using on each axis and fill those in. Be sure that the intervals are appropriate to the measurements you have taken. That's very important. We want to actually make this space in here useful. Okay, so you can see this example, 68 was the lowest mass for John, and 74 was the highest. So they decided to use a difference between 10 numbers for our intervals, and they went by 1 kilogram apiece. That gives us a better visualization rather than if they would have chosen to go by 5, 10, 15, 20. And also notice they started at 66. You do not have to start at 0. You don't have to start there. If you have numbers that aren't even close to 0, don't use it, because then your graph won't be as meaningful. Step number 4, 5, 6, 7. Well, 4 is really easy. You plot your data points that you collected on the graph. Now, oftentimes when you're collecting some data during your experiments, you're going to have a data table. And a graph is just another interpretation of the data table. So the information's in here, and now we just need to make it visual. Connect the dots, shade in the lines or bars, really easy to do. Put a title in there. This needs to offer a short explanation of what your graph is so the reader can quickly understand what they are looking at. There's various ways to do this, but one way we could use is what's the relationship between the dependent variable and your independent variable in your experiment. We did some practice questions, and we started them out with what is the relationship between, so we can use that same format in creating a title. If I did an experiment between the amount of dissolved oxygen and water temperature, here's my title. The relationship between dissolved oxygen and water temperature. Really simple. And a key if necessary. So if you have various colors or shades that you need to let the reader know, make sure you have a legend for that. So this might be off to the side, and we have this shape, what do they mean? Really simple. Here's 2 examples of a bar graph here and a line graph over here. The titles don't follow the format I gave you, but they are descriptive enough for me to understand what's going on. So let's practice. Take a few minutes in your notebook and try to create a data table using, create a graph using this data table. So right now press pause, write down your graph, and then I'll double check on that in a second. Okay, you should have had plenty of time to do that, and let's see how we did. Step number 1, draw the X and Y axis. And we need to label that. So we need to know what is the independent and dependent variable. Let's try this. Remember the sentence that we used. The dependent variable depends on the independent variable. So if I were to say the flower color depends on the number of insect species, do the insect species change the flower color? Not really. If I switch that around, the number of insect species depend on the type of flower. That makes more sense. So remember, over here we always have our dependent variable, and we just figured out this is our dependent variable, and our color of flower is our independent variable. All right, so I'm going to label this insect species, actually a number of insect species. Sometimes this is called species richness. We'll discuss that later. Down here I have flower color. Okay. So I've labeled each of these. I need to go ahead and figure out my scale. So I know my highest is 8. So I'm just going to go by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. And then we need to label this axis. So we have red, yellow, purple. Create your graphs here. We have 3. Did anybody create a line graph? We want to do a bar graph when we're comparing different types of 2 or more variables. And in purple we have 3. Okay. And then last thing we need to do is throw a title up here. The relationship between insect species richness this is a new term for you, and flower color. I kind of ran out of room here, but yours should look a little more professional than mine. So how did you do? Hopefully you did well. If you have questions, let me know. But this is how you should use, this is how you should create a graph using 7 steps.